Welcome to Pramod YouTube channel. Today I am going to discuss general mechanism involved in the anti-cancer agent. So, general mechanism of anti-cancer agent. Anti-cancer agent. In my previous video, I have given you the regarding what are anti-cancer agents and the classification of anti-cancer agents. Now, how does anti-cancer agents act? General mechanism I will give in this video, as well as the mechanism of alkylating agent. Two things I am going to cover: general mechanism, overall anti-cancer agent, and individual mechanism, that is how actually alkylating agent is going to act. Now let us see the general mechanism. To understand this general mechanism, we have to know the cell division process. So cell division process involves, first if you see how does the cell division takes place. Cell division. Cell division. So G1, I will tell you what is this. First I will draw it. G1, S, S2, G2, G2 to M, M2, this, and this to G0, G0 to G1. Now what is this? Is in a process of cell division. Cell division. Cell division. Now let us see what it is. Now what is this particular G1? G1 indicates pre-replicative phase. Pre-replicative phase. Pre-replicative phase. S is synthesis of DNA. Synthesis of DNA. Synthesis of DNA. This G2 is post-replicative phase. Post-replicative phase. And M is mitosis. Mitosis phase. Whereas G0 is resting phase. Resting phase. So what actually, how does the cell division takes place? First let us understand. In this cell division process, if you see the G1, pre-replicative phase, in this phase the enzymes required for the DNA synthesis have been synthesized. The enzymes required to produce DNA or the enzymes required to synthesize the DNA are being produced in this G1 phase, that is called as a pre-replicative phase of the cell. Okay, and once this phase over, they enter into the synthesis of DNA. So synthesis of DNA takes place. The DNA gets synthesized. DNA consisting of AT and GC. Okay, they are having base pairs. Adenine bonded with thymine, guanine bonded with cytosine. So synthesis of DNA takes place in S phase. So G1 phase is a replicative phase, S phase is a synthesis of DNA, and G2 is post-replicative. What this post-replicative means? Once the synthesis of DNA takes place, or once the synthesis of DNA took place, so what happens? The cell components which are required for cell division or mitosis are being produced in this phase. What they have produced? Cellular components are required for the cell division are being produced in this phase. And M means mitosis, which include the cell division, which determines the cell division. Cell division takes place during the mitosis. And G0 indicates G0. This is a resting phase. So mitosis to the resting phase. From the resting phase, again pre-replicative, the cycle will start. So this is in a cell cycle where the drugs will act on this particular phases, either G1 phase or S phase or G2 or M. So what are the drugs which will act on the different phases? Let us understand the things. So we are having different examples. We are having the different drugs anti-cancer, as we have seen in the yesterday's class. In this particular thing or this phase, during the G1 and the G2 phases, different drugs are involved. So like actinomycin, so they inhibit this particular phase. Actinomycin, 5-fluorouracil, cytosine, methotrexate, antimetabolites, methotrexate, as well as 6-mercaptopurine, 6-thioguanine, act on the phases between G1 and S phase. That is pre-replicative and synthesis. They will inhibit. Inhibit means negative charge. We have to use the negative charge. And the synthesis of DNA. During the process of synthesis of DNA, so the drugs like purine antagonist, like methotrexate, here also they will act. Methotrexate, cyclophosphamide, alkylatng agent, cyclophosphamide, 5-fluorouracil, so and daunorubicin antibiotic, daunorubicin act on this particular phase. Now when you come to the point of G2 phases, cyclophosphamide, G2 phases, what are the drugs means? Again here there is a cyclophosphamide is there, bleomycin antibiotic, bleomycin, as well as actinomycin D, actinomycin. So these are the drugs which will act on G2 phase. And what are the drugs which will act on the mitosis means? Vinca alkaloids, vincristine, vinblastine, taxanes, natural products, vincristine, microtubules they act, vincristine, vinblastine, paclitaxel. So these are the various drugs. And when you come to the point of G1, exactly at the G1 phase, hormones like hydrocortisone, hormones act on G1 phase, exactly on the G1 phase. So these are the anti-cancer agents, overall anti-cancer agents, where they will act at a different phase. So here we can see here they inhibit at this particular phases. G1 phase and S, in between those phase, actinomycin, 5-fluorouracil, methotrexate, 6-mercaptopurine, 6-thioguanine, they inhibit the phases between G1 and S. As a result, there is no cell division takes place. And also methotrexate, cyclophosphamide, 5-fluorouracil, daunorubicin act on the synthesis of DNA, inhibit the synthesis of DNA, thereby there is no further replication process takes place. And bleomycin, actinomycin act on post-replicative phase, thereby there is no cell division takes place. Whereas vincristine, vinblastine, paclitaxel, they directly act on the microtubules of mitosis process, cell division process, thereby inhibit the cell division. So as a result, there is no proliferation of cell takes place. No proliferation of cell takes place means no development of tumors or no development of cancer. Hence they are used to treat the cancer. This is a general mechanism involved in the anti-cancer agent. Now let us move to the mechanism of alkylating agent. One by one mechanism we will come to know, but in this video I am going to explain only about the mechanism of action involved in the anti-cancer agent. What is actually mechanism of action? So mechanism of alkylating agent. Alkylating agents we have already classified. Alkylating agents are of different nitrogen mustards, ethylene amines, as well as sulfonates, alkyl sulfonates. In all the cases, chlorambucil, cyclophosphamide, carmustine, lomustine, or else thiotepo, all the drugs, how they act means. So I will give you the schematic representation as well as how actually takes place the mechanism of action. Now the alkylating agents form a strong carbonium ion, form a strong electrophile carbonium ion means carbocation. So this carbonium ion binds to the nucleophilic site of the DNA base pairs, a DNA nucleotide, one of the DNA nucleotide. It binds nucleophilic sites because it becomes a strong electrophile. It will bind with the nucleophile, will give the electrons and bind. Strong covalent bond is formed between this case, and once they form a strong covalent bonds, there is a mispairing of DNA. Mispairing of DNA or cessation of DNA or abnormal in the DNA takes place. Abnormal in DNA. So abnormal in DNA takes place. But once it binds, it will inhibit. Majorly it will inhibit. What it will inhibit means DNA synthesis. No DNA synthesis takes place. And why means because of mispairing cessation of DNA. Now what happens? Alkylating agents, they form a strong electrophilic carbonium ion. Means carbocations they form. This carbocation act as an electrophile. They will get alkylated. So that's why alkylating agent, alkylated means positive ion will bind on the nucleophilic, means electron rich. This is electron deficient, binds with the electron rich site of the DNA nucleotide, which may be a guanine, adenine. So DNA nucleotide. As a result, what happens? Inhibition of DNA synthesis takes place. We have seen in general mechanism, the alkylating agents act on the DNA synthesis, inhibit on DNA synthesis. How they inhibit means they form a strong electrophilic carbonium ion. Once they form a strong electrophilic carbonium ion, they binds to the nucleophilic site of DNA nucleotide. As a result, inhibit DNA synthesis. Mispairing of DNA takes place, or cessation of DNA or abnormal in the DNA leads to the cell growth. Inhibition of cell growth or killing of cell takes place. As a result, they act as a good chemotherapeutic agent. So this is what the related to particular class of drug. What we relate means we relate that this is a particular general mechanism, but it is not as such. when you see that chemistry related mechanism of this, how they actually bind means, so you know that in all alkylating agents, in all the alkylating agents, you know that there is a structure called as like this. Okay, sorry, there is a structure, it contains NN diethyl amine. Here two chlorines are there, two chlorines, or maybe a methyl aromatic or cyclophosphamide, mechlorethamine, chloramphenicol dissolved. So how they actually bind with the nucleophilic site, that is what I am going to explain here. Now if you see here the chlorine which is present here, you can find what that chlorine is. Chlorine is a living group. Chlorine is a living group. So how the living group? What is a living group? It is an atom or group of atoms which take the pair of electrons and depart completely from the molecule. So what is a living group? Living group is an atom or group of atom which takes the pair of electrons and depart completely from the molecule. Now what is going to happen when you give the alkylating agents like mechlorethamine, chlorambucil, cyclophosphamide? The chlorine will get departed. It takes the pair of electrons. What it will take? It will take the pair of electrons. When it takes the pair of electrons, now it result into what means the same structure I draw. It mainly leads to, okay, the chlorine will take the pair of electrons. So when it takes the pair of electron, you can find what happens here. CH2 is there, CH2. This takes the pair of electrons, means this becomes electron deficient. Electron deficient means positive charge, electrophile. It becomes electrophile. So positive charge is formed. Chlorine takes the pair of electrons. I told you it takes the pair of electrons. It takes the pair of electrons and depart completely from the molecule. All the halogens act as in a living groups. Okay, so what happens means this becomes carbocation. Now it became more and more electron deficient. Now when it become more and more electron deficient, it requires, it will move towards the electron rich. So it moves towards the electron rich. So means here it contains lone pair of electrons. Nitrogen, we know it contains lone pair of electrons. It forms a ring-like structure and becomes strong electrophiles. I told you the alkylating agent becomes strong electrophile. Okay, strong electrophile. Now this strong electrophile, what it will do means, now if you see the structure of the particular structure, if you see, you can find guanine. Now guanine is present in the DNA. I write here for your understanding. Guanine is present in the DNA. So DNA structure, you know that it is helical structure. Say that in this helical structure, sorry, now when we see this particular thing, simply for understanding purpose, so this containing guanine, okay, so adenine, guanine, cytosine, thymine, purine and pyrimidine nucleotide present. So you think that this is a DNA. In the DNA, what happens? Guanine is a purine nucleotide. I draw the structure of the guanine. So that purine. Okay. So purine. Fine. Pyrimidine fused with imidazole. guanine type of structure I drawn. So purine nucleotide. Now what happens means generally this particular electrophile and the particular seventh position, okay, 1 2 3 4 5 6 7, seventh position containing the lone pair of electron, they go and attack on these electrophiles because this is nucleophile. So seventh position of nucleotide go and attack on positive charge. This is nucleophile because nitrogen is having lone pair of electrons. So what bond is forming means they form a covalent bond. What bond is formed? Covalent bond. Covalent bond. So as a result, what happens? This is, you think, guanine. So instead of guanine pairing with cytosine, guanine will pair with the alkylating agent. This is alkyl. They get alkylated with the nucleophilic site. This is a nucleophilic site. Nucleophile. Nucleophile means electron rich. This is electron deficient. So electron rich and electron deficient both will bind covalently. As a result, strong bond is formed. So guanine is not available to pair with the cytosine. As a result, mispairing takes place. When mispairing of DNA takes place, there is no proper replication, there is no proliferation of cells, and the cell's growth is inhibited. This is what the mechanism. So alkylating agent forms a carbonium ion, strong carbocation, which is electrophile. This electrophile bind on the seventh position of nitrogen, seventh position containing nitrogen, which is having a lone pair of electrons. The nucleophile electrophile reaction takes place. Both will bind stronger, and when it bind with the stronger, mispairing takes place, abnormal of DNA takes place, then cessation of DNA takes place. There is no further replication of cancerous cells, thereby inhibition of cancer takes place. Similarly, this chlorine also goes and the process will continue. In other way also you can find what is going to happen means in other way also same. Okay, this chlorine also leave and that chlorine also leave and that also form same as this particular thing. Okay, again another carbocation is formed, again it will go and bind to here. Okay, so the process will be continued. They become more carbocations, more this thing. So the process will continue to bind with the DNA. As a result, finally there is a inhibition of DNA synthesis takes place. There is no further replication. So this is what in this video you have gone through. We have discussed about general mechanism of the general mechanism of anti-cancer agents, followed by mechanism of alkylating agents. If you have any doubts, you can pin to message to me in the YouTube on comment box. Thank you.